Hello, hello. All right, folks, here we go. We're on to section 7.2, and 7.2 is working with similar polygons. So where we're at today here, if and only if their corresponding angles are congruent, corresponding side lengths are proportional. So as you see in this sheet right here, you see this mark right here for angle A matches up with the one mark with angle W. So you can see we made a statement right here. Angle A is congruent to angle W. You can see B, same thing matches up here with B and X. You can see the two slashes there, and C and Y, you see the slashes there. And then these symbols right here you also look at, and you notice the first letter is A matches up with W. B matches up with X. And so you can also look at it that way and set them up that way. Also, what you want to see is once you see that those angles are the same, now we can set up the side lengths are in a proportional statement. So AB is 15. We put that, let's see if you start with that, so you put that one on top. WX is 5, so you put 15 over 5. Again, this is showing that we have some proportion here. Next one you can see we have BC. Here's BC, and here's XY. So 12 over 4. Okay? And then we have this one right here. We have 21 and 7. And then the last one we have 18 and 6. And as you can see with all of those, they are in proportion. And then ultimately you want to get to this right here. That's a 3 to 1. So you want to get that to be a 3 to 1 ratio. So that's what we mean when we say similar polygons. The angles are the same, and then the sides are in proportion to each other. So here we go. Two polygons are similar if and only if corresponding angles are congruent. We just did that. And their measures of their sides are in proportion. So again, that means we have the same shape. So same shape right here. I don't know if we can see that. Maybe a different size. One may be bigger, one may be smaller. And if a polygon is congruent, then that means it is similar. And then we just mentioned through the scale factor how we did that, side of one over the side of the other. And that's how we get a scale factor. That's how the scale factor right here is that's how the ratio used to compare the similar figures. In a similarity statement, we saw that with the last slide. So this example right here, list all pairs of congruent angles and write a proportion that relates to the corresponding side. So again, this right here is the similarity statement right here. So that you can match everything up with that statement. So even though nothing's marked on our picture, the first letter is A. That means angle A matches up with angle R. So angle A is congruent to angle R, and you can get that from that similarity statement. Angle B is, we put the two slashes, matches up with S. So angle B is congruent to angle S. And then the third one, we go with 3 here, 3 here. Angle C is congruent to angle T. And why can we only do one letter here? Because there's no extension or combination here. Second thing we want to do is next we want to write a proportion, our sides in proportion. So this side right here, the first one we have is AB, AB right here, and RS right here. So it's not that they're equal, but we set up a proportion. So AB over RS is congruent to what's the next side right here? So BC over ST. And then the last side right here, we'll make this one a square. So we can go AC over RT. So this shows you a proportion of the sides to put the sides in a proportion. So this kind of walks you through the same thing, gives you the same answer that I just went through there. So here's a example for you. Determine which of the following similarity statements is not true. Is not true. So if you look here, angle HGK, HGK is right here. Is that with QPR? QPR. So again, does G match up with P? Does G match up with P? Yes, that one's good. So the next is GH. So GH and PQ, that's right here. Go with GK and PR. Yep, those two match up. Does angle K match up with angle R? Yep, that one works. The last one is GHK. GHK is right here. Does that match up with QPR? Does that match up with here? So does H match up with P? And that would be a no. That one does not work. So the one that does not work is D. That's the one that is not true. So again, example of similar polygons. So in this case here, we have a similarity statement, pentagon. You match up the letters. So A matches up with R, and you can go through that way. Those angles match up. So that's what we would look for with corresponding angles. And then for corresponding sides, you would do something along the lines of, that's one way is AB. So here's AB matches up with RS. So AB over RS. And then you would set up all those other sides equal to each other. Then the last thing we want to take a look at is, what is our scale factor? So if we start with this one, so that one is 3. And then this one's second, and that is 3 over 10. So your scale factor would be 3 to 10, or 3 over 10. Okay, next slide here. They say that the two polygons are similar. Write a similarity statement and find x, y, and uv. So start with a similarity statement. So polygon, and I usually start with A, B, C, D, E is similar to, and what do you have to match it up with? What is it similar to? So polygon. So what matches up with A is R. So A and R match up. So you'd go polygon R. B matches up with S. So we go S, and then you can see we do flow S, T, U, V. So that right there is a similarity statement. That's a similarity statement. Then it asks us to find X. So how do we find X? So where's X? Here's X right here. And that matches up with that side right here. So X equals 3. X is 3. So what is the next thing? Well, X is not 3. X is in a proportion here. So what we want to take a look at when we're doing the side. So again, let's go back to how we solve a side. First thing we want to do is we want to find a ratio here. So if you see, we have a 4 and a 6. So we have 4 and a 6 is our ratio, so we want to reduce that to 2 to 3. So we have a 2 to 3 ratio, or in this case, with this one on top, it should be a 3 to 2 ratio. Okay, so if we're going to go with a 3 to 2 ratio, then what we want to take a look at is we use that to find our answer. So if we start with this one, then the 3 goes on top. So 3 over 2 equals, if we did this to this, so X over 3. So hopefully, we got the 6 to 4 gave us the 3 to 2, and then we started with this side, so we're going to put this one on top, this one on the bottom, cross multiply, which is what we did in 7-1. So this gives us 9 equals 2x. You divide, and x is 4.5. So that's how we find x. They now want us to find y, so again, use the same 3 to 2 ratio. So 3 over 2 equals, and we want to find, here's y is associated with this, so 8 goes on top because we started with this, and the y plus 1. So now let's go and solve this right here. So you'd put this in parentheses. So 3 times y plus 1 equals 2 times 8. So 3y plus 3 equals 16. 3y equals 13. You divide, and y gives you, that's 4.3. 4.3 repeating. So that's y. And then the last thing asks us to solve for uv. uv is right here. So to find uv, you go y plus 1. This is y. Add 1 to that. uv equals 5.33 repeating. So that's how we're going to solve that specific problem there. Let's take a look at the next one. It involves a menu. And it says, determine whether the size for the new menu is similar to the original menu. If so, write similarity statement and scale factor, explain reasoning. So first thing you want to do is you want to match up a scale factor. So this is 10 to 12. This one right here, A is 10 to 12. And this one right here is 12 to 14. So we can check to see, do these match up? You can reduce them. You can cross multiply. This one's probably easy just to reduce. Take out a 2. You get 5 over 6. Does that equal 6 over 7? It does not. So therefore, they are not similar, and we would move on from there. This walks through the same set. Just let you read through that on your own. You can pause that. Let's take a look at this one. Same idea, same concept here with menus. You can try that one on your own if you want. There you go. There's an answer key here. Those did match up. So those two are the same with a scale factor of 4 to 5. Here's another example that you can test and see. Does this one work? Again, so you have an 8 to 6. So here you have an 8 to 6. Does that match up with a 16 to 12? So a couple different ways to look at this. Again, you could reduce them. So this is a 4 to 3. Take this out, 4 to 3. So again, same concept here. Are these the same? So when you look at these, you're actually not comparing the 4 to 3. So we're taking a look to see how we did on those and to see does that match up. So this is the next step in our process here. So this one right here, so they give us a triangle with a scale factor of 2 to 3. So let me just see something real quick here. So they give us we have a scale factor 2 to 3. The lengths of the sides are 6, 8, and 10. What are the length of the sides? So we have to set up a proportion. So again, if you take a look and see where we're at. So we have a ratio of 2 to 3. So ABC is 2 to, so because again, why is it 2 to 3? Because this is ABC and this is XYZ. So 2 to 3 ratio. They tell us that the lengths of ABC are 6, 8, and 10. So you do 6. 6 is associated with the 2, and you want to find what does that equate to in XYZ. So when you say X is 9, that is one of the sides in the triangle XYZ. The 6 is with triangle ABC. You do the same thing here for the next one, same thing for the next one. So the lengths of the sides of this triangle XYZ are 9, 12, and 15. Almost done here, folks. So perimeters, so you can also set up, we have a theorem here that if two polygons are similar, their perimeters are proportional to the scale factor between them. So you can set up a scale factor, and then you can find a perimeter if you have one of the perimeters. So this specific example right here, this is a similarity statement. Find the scale factor of ABCDE to that and the perimeter of each. So when it says find the scale factor, you want to find what sides match up to each other and to be able to get that to work. So when I look at what we have here, I see we have a 6, we have a 4, we have a 7, we have a 10.5. So when you look, you say, well, the 4 is over here and the 7's over here. So you can move the 7 and you can move the 4 because these two are equal. So our scale factor of ABC, if ABC is first, it's a 4 to 7 scale factor, 4 to 7. So when you look at these two, which of these two can we find the perimeter of? And so we have to be able to find the perimeter, and then we try to match it up from there. Okay? So you're going to have to use the scale factor to get that. So right now we have a 4, and we have a 6. We don't have these two. We have a 7, we have a 7, and we have a 10.5. So we don't have this. We can get 10.5 here. So we have to use the scale factor to find one of our sides that are missing, and then we can go with the perimeter from there. So taking a look at what we have a scale factor of 4 to 7. Okay, so 4 to 7, and let's say we wanted to use this 6 to find this side right here. So we're going to go 6 over ST. So that's going to give us a chance to find our ST. Okay, so 4, and so we can go 4 times ST equals 42. So what do we do there? We take that 42 and divide that by 4. And that gives us that ST is 10.5. So in terms of finding the perimeter, we now can find the perimeter of this object. So with that in mind, so we can find the perimeter. So add these all, 7 plus 7 plus 10.5 plus 10.5 plus 10.5. So adding all those up, that gives me a perimeter of this object over here of 45.5. So yeah, you could try to find the side over here, or we can just simply use a perimeter. So we're going to use that 4 over 7. And remember, our perimeter was with the bigger one. So that's 45.5 goes here. And we're just going to put P here for perimeter. So that's our proportion. So 4 times 45.5 equals 7P. So 45.5 times 4 equals 182. So 182 equals 7P. So you're going to divide that by the 7. And I find that my new perimeter, or my perimeter of the smaller object, is 26. So that's the perimeter that will go right here. So you can use the scale factor to also find a perimeter. And they walk you through all this. I'll let you read this slide now that it's up there. You can read through that. And then this shows you again the same concept here that I just explained. So now I want you to try this one here on your own, see what you come up with, and hopefully you find that you get the answer to D. You get the answer D. So again, match it up, find your scale factor first. This I can use a scale factor right here. Again, whatever you start with, it starts with the L, so 8 to 6. I would reduce that, take out a 2, so I have a scale factor of 4 to 3. And then go and find your sides and find one of your perimeters, and then you can do the proportion from there. Great job.